Hello friends, welcome back to my channel Varteta Learning Platform, and in today's video we are going to discuss a bit about the STL set. So we are going to discuss about the set. So set is an associative container. I hope you are aware about the associative containers. So associative means there is a key value relationship. In case of associative containers, there is a key value relationship. With every value there is a key associated, unique key associated. Okay. So but in case of set there is no key value relationship, although the concept is same, but the thing is that the key and value both becomes same, and key itself becomes the value. Key is the value itself and key is unique. It will remain unique. For set there is another STL, standard template library object, which is known as multiset. In that case you can see that it may be non-unique, it can be duplicate as well. Okay, so for the sets we can understand few things. Like, first thing is that it has been implemented as balanced binary search tree internally, which means that internally this has been maintained as a balanced binary search tree, the set. Okay, and every key is a node to the balanced binary search tree, node to balanced binary search tree, BBST. So this is the internal implementation detail of the not detail, basically the internal implementation data structure detail, like what data structure has been used. So it's balanced binary search tree. And about the balanced binary search trees, you might have studied in the data structure. So even if you have not studied, there is one playlist in our on our channel. So in that playlist you can see that there must be something related to the binary search tree. If it is not there, then very soon we will be uploading some video on the balanced binary search tree, or you can say the AVL tree. So this set is maintained as the balanced binary search tree internally. So this you need to remember. And the important functions, like which you need to understand is like it is insert. That function is there. You need to insert the values, and then you need to, if you have to iterate through it, then there is iterator. So just like other STLs, iterators and the container, all those concepts are also here. So this is the way you can use it. So let us see that how we can create a set and how we can use it, right? So before you use it, you need to know the header name, and the name of the header which you can use is set. Okay, so this is the header which you need to use. So this is set. So let us see. So this is the online debugger that I'm using here. So let me create set hash include set, and then I need to create a set integer. And then when you are creating a set, then you need to tell two things. First thing is that what kind of value you are going to save. So the value, the type of value, the kind of value that I'm going to store is integer, and in what sequence you are going to add it. So the second argument is like I want to store it in the uh, in the reverse reverse order of big to small, right? So the right word I'm not able to say. It's like in the descending order. Oh my god, this word was not coming into my head. Okay, so we are going, if we want to store it in the descending order, then we need to take this greater int. Okay, so greater is it is a functional object, basically, which has been already provided by the STL, and it should be included with the help of functional. Okay, so these are the things. So let me create the variable s, and let us see first by running it, like if all the things are fine or not. Yes, so functional is the header that you need to include, and apart from that you need to include the set header, and you need to then create the set object. So you have created this, and then s dot insert, and you need to include 10. I'm inserting 10 in this set. I'm inserting then 20, then I'm inserting 14, Okay, so let's see if I have called the correct function or not. Yes, I have called the correct function. So since I have given this predicate, this which is the greater predicate, which means that whatsoever is the greater, that will be arranged first, that will come first. And that is why when I will show this set to you, in this set you will be able to see, when I will print it, you will be able to see the values arranged in the a descending order. Okay, so let me just show you. So the values that when I will print it, they will be like 20, 10, and 20, 14, and 10. Okay, so how we can print it? So I can use this for each. I hope you know about this for each. If you don't know, you can read about it from our other videos in the same playlist. So for each, I'm going to do s dot begin. So I'm just going to set the boundaries, that from which position to which position I have to iterate through. So s dot begin, s dot end, and then what I need to do, I need to print it. So for printing, either I can use some function, or I can do one thing, I can simply use the lambda expression. I hope you are aware about the lambda expression. So here you can see like int I can take this int I, because this one argument which is of integer type, that will be passed using the for each, because internal implementation of for each is that from here till here, it will pass one by one every element to this function, which is basically a lambda function as of now here. Okay, so let me do this. So I will simply print all the things, cout, en real, and then what I will do, I will simply print I, and here I will close it. So now when I will print it, you will be able to see that 20, 14, and 10, in this manner this has been printed, because this greater has been used. Okay, so now let us write our own predicate. Okay, I am going to write my own predicate, and using that predicate I will now arrange it in the ascending order. Right now this is in the descending order, I am going to arrange this in the ascending order. So for the ascending order, I'm not going to use any of the existing library functions, any of the existing library predicates. Rather, I'm going to write my own predicate. So how I will write that? So to write that, I need to write something like this. I am just going to write a functional object. So let me make it templatized. Template class T. Why I'm making it templatized? I don't need to make it templatized, but the thing is that when you are studying few things, when you are learning something new, then whatever you have learned, then you should use that constantly, again and again. You should use those concepts so that you are in touch with those. Okay, so I'm just going to write like class smaller, and then I'm just going to write like this, and then I'm going to write like public, and inside this I'm just going to write I need to make it a functional object. I hope you are aware about the functors. So I'm just going to create it as a functor, templatized functor. Functor means any class which can be used, whose object can be used as a function. That class is known as the functor. Okay, so that I'm going to do. So smaller, and no, not smaller, I need to simply write like this operator, and here I will take the value t value, and I will print, I will just simply t value 1 and t value 2. Okay, so since this greater, it maintains like I will work on the integer, but in fact this greater predicate has the functionality like it takes two arguments, and it only compares whether the first value is smaller than second or greater than second. Since it has to be greater, so based on the greater check it will return true. Similarly, here I will return true and false based on the first value is smaller or greater, based on that. So value 1 is smaller than value 2. So if value 1 is smaller than value 2, then in that case it will return true or false. So this is the thing, like this is predicate. Predicate means anything which returns true or false. So using the smaller, I am going to return true if the first value is smaller than second. So internally, when I will use smaller here, then what will happen? that when we will be inserting inside the set, then in that case this value will be passed and compared with all the other values using this function, this functor. So when this will be used against this functor, then in that case it will automatically, while inserting, it will automatically be able to arrange the values in the ascending order. This has already been implemented inside the insert, that how it will manage to store the values in the ascending order, and to maintain those values in the ascending order, the helping functor or the helping function object it will use is smaller, just like earlier it was greater. So now I am going to use this smaller. I hope you are aware about the functors. If you are not aware about the functors, you can visit our C++ playlists, and in the same playlist as well we have discussed few concepts related to all these things. The other standard template library and algorithm related things we have already discussed, so you can reach out there. Okay, so let us see. Let me run this. Now you can see that 10, 14 and 20, this has been printed. So this is the way you should practice the STLs, not just like taking some example and just learning it by heart, that yes, this function will do this, that. When you will do these things, when you will play around with the functions, functors, when you will be play around with the algorithms that have been provided by the STL, standard template library, then you will be able to open your mind with respect to the STLs. And that is the whole purpose of this playlist, is to make you well versed in the STL. So I hope you might have understood. And if you don't know about the functors, you can read it separately. There are number of other playlists with the name of C++ tips and tricks, not basically tips and tricks. There is another playlist on my same channel related to C++ concepts. So on that you can go, and I have discussed this thing in some playlists. So I don't remember exactly where, but yes, I have discussed it. Okay, so please be with me, and please keep learning. Thank you. Have a nice day, and bye.